Okay, so I haven't graded the test yet, but hopefully try to do it soon. Okay. Anyway, last time we were taking a look at generics, right? And the key concept, if you remember, was anytime we need to create code that will that can be used on different data types, generics make sense, right? So anytime we have data involved, for example, the classes that deal with data structures. Okay, for example, we may have a linked list, we may have a queue, we may have a stack, hash table, right? All of these, because, you know, for example, if we are creating a list, we may want to store integers in the list, we may want to store strings in the list, right? So it makes sense to have it as a generic. So now generics also give us what we call type safety. So also give us type safety. So in modern software development, you should always be using generics, okay, as opposed to using you know, plain object. So remember, previously, to get more flexibility, we were using, for example, an object, right? If we needed to create an array of objects, what was the most popular collection? Arraylist. Okay. So if you created, for example, Arraylist, let's say slist equal to new Arraylist. Okay. So remember, we discussed that anytime we store something in the array list, it becomes an object, right? Yes. So for example, I can create a student S1 equal to new student, and I can do slist dot add, for example, S1, right? So if this is our S list, as soon as we store S1 in it, what happens? S1 gets wrapped around as an object, correct? So what if I did, for example, a string, let's say st equal to hello. Okay, can I also do slist.add st? Will this work?
Yes.
Right? So remember, Arraylist is totally flexible. We can add student, we can add a string. So sure, it will work. Hello, right? And so on. So now, if we wanted to write a code to go through the Arraylist, and if it's a student called the compute grade on it, what will our code look like? So our code will look something like this. We will say for each. Okay, can I do something like this? Student st in slist. Will this work?
No.
Okay, and the reason it will not work is, see, think of it this way. Student st is a reference capable of pointing only to a student. Okay, so very first time through the loop, sure, this will be okay. But second time through the loop, what will happen? Can st, which is of type student, point to a string? No, so that's when it will generate the runtime error, right? So what's the type of reference that can point to a student as well as string? Object. So we will change this to object obj in slist, right? So now let's change this. So can obj point over here? Because object is the base class for all classes, sure it can, right? Can we now do obj.computeGrade? Will it work?
No.
And the reason it won't work is this code won't even compile, because what type is obj?
Object.
Object. An object class does not have a compute grade method, so the compiler won't even let us run the program, right? So what's the solution, if you recall? Is or as or reflection, right? So we will do if st is, sorry, if obj is student. So we'll check, is obj pointing to a student, right? Then can we do obj.computeGrade? No. Still not, because obj does not have a method called computeGrade. So then we create a reference of type student. So we can say student s equal to student obj, correct? So we make s point to same place obj is pointing to, and through s we can call compute grade. So this would be the approach if we were using an array list to store data, right? Okay, so it may not seem that bad, but let's now assume we have, let's say, 1 million entries in our array list, okay? So, and some of these are students, some of these are other type of objects, right? So you can see if half of the million are, or even if you know, it's a small number or large number of the million things over here are students, we have to perform this check how many times? How many times we have to perform this check? 1 million times, right? Because we are going through a loop 1 million times. And remember, we discussed this, that checking whether we are pointing to a student is an expensive runtime operation. We have to go to the object, we have to go to the, once it's pointing to the vtable, and then through the vtable type info, before we can determine that it's really a student or not a student. So our code will run very slow, right? So instead of using an array list, now let me show you if we use a generic type of, so the equivalent of the array list is called list in the .NET library. Okay. So instead of the array list, if we use the generic list, all this checking whether we have a student or not will be avoided. Plus, at compile time, the compiler will verify that we are following what we call type safety. So anyway, so there's already a built-in class called list. And remember last lecture we discussed for a generic class, after the name of the class, between less than, greater than, you indicate the type of data you'll be storing in it. So if your goal was to store students, this is what you will do. List of student, let's say st list equal to new list of student. Right? This is how we create a generic, an object of a generic class. Okay, once we do that, rest of it is very similar to the array list. Then we can create a student. So for example, student s1 equal to new student. And then we can say stlist dot add s1. Okay, so just like we did before, that's very similar, right? However, there's one difference now. Okay, if you created, let's say, a string, let's say s2 equal to hello, and you try to do stlist dot add s2. So you try to write this code. Okay. Now this code will not compile. Okay. Why will it not compile? Because how did we create stlist before? We said only either a student or something that is derived from a student can be stored in it, right? Is string derived from a student class? No. So the compiler won't even compile this. So it is impossible to write this type of code. Okay. Only things that we can add is, so we can create other students. So we can say student S1A equal to new student. We can add STList dot add S1A as an example, right, and so on. Okay, so how will we write the for loop now for each loop? Okay, the for each loop now will be written as for each. Now can we write student ST in STList, right? Because if you take a look, now it is guaranteed that everything over here will be of type student, okay? Because it's a generic list, okay? So because it's guaranteed everything will be a student, can we just say st.computeGrade? Do we have to do the is or as operator like we were doing over here? Is there a need for it now? Yeah. So no need for it. So the code becomes extremely efficient, as well as, so this is what we refer to as type safety, that nobody can add a different data type other than the one we declared in the beginning. So it gives our code a lot more reliability, as well as higher efficiency in execution. So from now on, never use an array list, okay? There's really no need for it. If you have to store data, create a list. If you wanted a stack, again, there's a pre-built class stack where you can create a stack of integers or stack of doubles and so on. So a lot of the data-related classes that are already in the library are generics to begin with, right? If you are creating your own very special data structure, you can make it generic, just like we discussed last time, right? Okay, so to emphasize the type safety as well as higher speed of execution, let's take a look at our sorting code that we had written before. Okay, so if you recall, we had created the student class, and to allow sorting, we had discussed to implement iComparable or iComparer, right? So if we wanted to sort on one field, we provide iComparable interface implementation, right? Now suppose we have 5 fields over here. What was the method in the iComparable interface? Compare to, and what does it return? Integer, right? And if the two things we are comparing are same, it will return 0. If one is bigger than the other, 1. If one is smaller than -1, right? So the way this iComparable is written is, I forgot whether it takes the object, yeah, it takes the object, let's say obj as the parameter, okay? So how will this be triggered? Let's say we created, for example, an array list. Let's call it SList, okay? And suppose we added a lot of students to it. So we did slist.add S1, S2, and so on, right? So slist.add S1, and then S2, and so on. Okay, so we have, let's say, 100,000 students added to the array list, right? Okay, and then if we did slist.sort, okay, so remember we had discussed sort, quick sort is already built into the array list, and through this we can call the sort method. So as we call the sort method, what it will do is it will try to compare the two to see whether it should rearrange them or not, right? So internally the sort will try to do S2.compare to S3 and so on. Okay, so this is the internal code of the sorting, right? So our job was to provide the compare to. so that the sort method can compare and rearrange the objects, right? So take a look over here, the S2 now is the object obj in this example, right? And S1, through S1 we are calling, so if we use this keyword over here, what will it refer to? S1, right? Okay, so the way we had written this code, if you recall, first thing we need is to verify, is this a student? So we had written something like, if obj is student, okay, and then we will do something like student st equal to null, for example, right, before this. Then we will say st equal to student obj. So we'll convert the obj to a student, correct? And over here, let me also put int ret equal to 0. So now we will do ret equal to this dot, for example, id dot compare to st.id, correct? So we'll compare the two IDs. Let's pretend we wanted to sort them by IDs, right? And then we will basically return ret. So this is how we had programmed it before, okay? So again, every time this is called, we have to go using the vtable, using the type info, verify we are pointing to a student, then typecast it, then do the comparison on the field, right? Okay, so because quicksort is provided by the Arraylist, our job was only to write these 4 or 5 lines of code, and it may seem like, oh, this is really neat. We can do the sorting just by writing 4 or 5 lines of extra code, right? But what about the execution time, okay? What's the time complexity of quicksort? Okay, okay, remember O of n log 2n, correct? Okay, so if we had, let's say, 1 million students, 1 million is roughly 10 raised to the power 6, right? So how many times will this be called, roughly speaking? N will be 10 to the 6. What's log 2 of 10 to the 6? Okay, log 2 of 10 to the 6, see, 2 raised to the power 20 is close to 1 million. So log 2 of 10 to the 6 will be roughly 20, right? So how many times this will be called? 20 million times, if we have million entries in the array list. So 20 million times, you are starting from the obj reference, you are going to the vtable, you are going to the type info, you are verifying it's a student, then you are typecasting it, right? So now, as you can see, our code will run quite a bit slow because we are repeating these things 20 million times, right? Okay, so as opposed to, what if we use a list instead of an array list as an example, right? So just like we have generic classes, right? And we have generic methods. We also have generic interfaces to make our life easy, make it more efficient, right? So just like we have iComparable, there's also iComparable T is our generic interface. So that means whatever type T we wanted to operate on, we can write the compare to for that type T, not just the plain object over here, right? So now let's switch to the generic list and the generic iComparable T. So if you were developing this code, what will you do? Make this iComparable student, okay? So since we are implementing generic eye-comparable. So as soon as you right-click on it, go to Quick Actions, Implement Interface, what you will notice is it writes public and compare to. But instead of giving you object OBJ now, it will give you something like student ST. Okay, so something like that. We may call this something else, but it doesn't matter, but this will be of type student, right? Because it's of type student, do we have to do verification now? No. So there's no need for this. There's no need for this, right? There's no need for this. And we can simply do return, return. Okay, so return this.id compare to st.id, right? So now if we are triggering it 20 million times, we are avoiding going to the vtable and the type info 20 million times. So the code will run extremely faster, okay? So to summarize, don't use Arraylist, okay? Only use generic lists if you have to store lot of data and you need the flexibility that it can grow in size. Okay. If you have to use interfaces, especially the iComparable, iComparer. Okay, also has the generic version of it. Okay, iClonable does not have the generic version, so no generic version. Okay, so this one will stay the same as we had discussed before, but that's not a big problem, and the reason is because once we do the cloning, we only clone a few objects, okay? But however, once we need the comparison, for example, in sorting, we call it potentially millions of times. So the speed and the accuracy, speed advantage and the type safety is more important over here, so it's provided to us over here, right? Okay, so now let me show you another feature of generic classes and generic methods and generic interfaces. Okay. Okay, so see, a lot of our code these days, as you develop different applications, our data for our code comes from databases. Okay, so if you work as a computer scientist in any company, you'll be dealing a lot with databases, right? So if we are developing an application, okay, rather than, for example, if you created a form, you click on a button, you wanted to display some data by bringing it from the database, rather than writing the entire code in the click event handler, the button click handler, and writing all your database code, all your display code, okay, that's considered not a good practice. When we create a proper, well-designed application, we are supposed to develop it following what we call the single responsibility principle. Okay, what is the single responsibility principle? What it basically says is, if we create a class should have one responsibility. Okay, for example, if the class is related to the user interface, it only should worry about displaying the data in the user interface. If the class is, its job is to bring the data from the database, it should only focus on bringing the data from the database. If the class is going to apply some business rules, it should only focus on business rules, right? As opposed to just writing not only the UI code over here, but the database code over here, the business code over here, this becomes all mumble jumbled, and it becomes very difficult to maintain and upgrade, right? So typically what we do is we create a layered architecture. So proper design is what we call layered architecture. So very briefly, what does, so in this layered architecture, we follow this single responsibility principle, right? So this is what we do. If this is our database, all of our code that deals with the database, we refer to it as a data layer, okay? So we'll create some classes which deal with going to the database, opening the connection, issuing the SQL, and so on. So for example, if you recall, we already had created this data access class. Okay, that was part of the data layer, right? Okay, now as we go to the database, we also need to compose different SQL. So for example, if you wanted to know, has the student taken prerequisites for a course, you will need to write the SQL, right? Then you will need to open a connection to the database, issue the SQL. So to further make it a little cleaner, what we do is all of our SQL that we compose, we put it in another class. Okay, so this is a class, here's another class over here. So its job is to compose SQL based on our need. Okay, so these two together become our data layer. So in this class, we will write small functions based on each of our needs. We will compose the SQL, then call one of the methods over here to get our job done, right? So to give you an example, remember once we created the data access class, if you recall, we had written 3 functions inside this class, right? What were those 3 functions? So get single answer. It took a SQL as an input, correct? And returned an object, right? Okay, very similarly, we had something get many rows, columns, right? Something like this. Also, it took the SQL as an input and gave us a data table. Okay, and lastly, if we wanted to insert or update or delete, and then this will give us how many rows were modified, right? Okay, now let's pretend you are trying to create a student application such that somebody can register for a course, somebody can unregister for a course, somebody can view their transcripts, so view grades, and so on, right? So in fact, your next assignment will be, you guys did one student database example before, but now you will develop it into a full-fledged, with a proper architecture. So anyway, so let's pick one example. So suppose you wanted to know, students registered in, let's say, CPSC 440 class. Okay, so that's one of the capabilities you needed in your application. Okay, so obviously we need to compose SQL, right? It may require joining 2-3 tables, right? So rather than writing more and more methods over here, what we do is all the composition of SQL is done in the repository class, okay? So in our repository class now, we will create a method. Okay, so for example, it may say get enrollment will be the name of the method as an example, right? What will be the parameters or the input to this method?
SQL?
No, not SQL. SQL is only in these 3 methods.
Student ID.
No, enrollment for a course.
Oh,
Okay.
for course.
Right? So we will have string, let's say course num, CNUM as a short. And what will it return back to us? List of what? A list of students, right? Because we wanted to know the so the reply from here will be list of student. Everybody agrees? Okay, so rather than returning an array list or a data table from a repository, we always return a strongly typed data. Okay, so it will never be from the repository onwards. Okay, here these will always be strongly typed objects. Or lists. Okay, all the data related, for example, data row, data table, object, it's okay to write that over here. So all the low-level details are over here, but the idea in a proper application design is that rest of the application always deals at the more language, class objects, and strongly typed lists. Okay, so anyway, let's try to write this method now, just to give you an idea of how this will look like. Okay, so basically what we need to do is we need to first create an empty list of student, let's say ST list. Equal to new list of student, correct? And pretend you've already created the student class with whatever fields you wanted to return, right? Okay, now we have to compose the SQL, okay? So now let's go to try. And what will our SQL look like? So our SQL will look something like this. Okay, select. Okay. Anytime we are joining tables, hopefully you guys have already gone over it. Okay, if you follow my philosophy of writing SQL, joining tables, no matter you're joining 3 tables or 20 tables, becomes very easy. So if you remember the guidelines are like this. Assign an alias, like a nickname, to each table. Okay, and then join one table at a time. So in this case, let's pretend in our database we have students table, we have courses table, and we have enrollment table. Okay, so student, let's pretend have columns like student ID, first name, last name, and so on. Okay, courses, let's pretend we have course num, and name, course name, and so on, and credit hours, and so on, right? Enrollment basically gives us a student ID and a course number. So for example, let's say there's a student 1, 2, 3, 4, 7, okay? That's the ID, and if the student is enrolled in course computer science 440, the course number will be 440, right? The same student can also be enrolled in another course, for example, 555, and so on. Okay, so this basically tells us which student ID is enrolled in which course, right? Okay, so now let's pretend the list of students that we wanted to return from here will also, let's also make it, all right, so first let's just try to return the student ID, the first name, the last name, just the three things, right? So what will our SQL look like over here, this SQL? It will look like select S dot. So pretend S is the alias for student, C is the alias for courses, and enrollment is E, right? So this will look like S dot student ID, comma, S dot first name, comma, S dot last name. Okay, let me, if you wanted, okay, just for the sake of fun, let's also pretend we also wanted to return the name of the course, okay? So because that is in the courses table, so C dot course name, right? So then now we'll follow the next rule, join one table at a time. So you will do from students S. So this is the time you assign the alias to the table, and then join one table at a time. So you will do inner join courses C on. So we assign the alias for the courses table, and we will say S dot. Okay, now if you take a look between the student and the course, there's nothing common over here. Okay, however, this student ID matches over here, right? So I should not be joining courses first. I should be joining enrollment first. So enrollment E on. Okay, and it will be S dot student ID equal to E dot student ID. Okay, now we can further do, let me go over here. Okay, inner join. So now I can join the next table, courses C on, E dot course num equal to C dot course num, where C dot course num equal to computer science 440 as an example, right? So this will be our SQL that we will obtain, that we will write to join the three tables of student, courses, and enrollment, right? So again, if you do not want to return the course name, you can take this field out, okay? But if you wanted to, you can put that there, okay? So anyway, once we have composed the SQL, right? Now we are writing this inside this repository class. Okay, so now to get the actual data, what do we have to do? Contact the data access. So which function will we call over here?
Data access.
Get many rows.
Get many rows, right? So now our code will do something like this. Data table dt equal to, pretend the repository object is already created somewhere over here. Sorry, data access. I data access. If you remember, we had created an interface first. So let's call it IDAC equal to new data access, right? So now through IDAC, we will do dot get many rows and columns and pass it the SQL, correct? So now this will trigger this method, which will open the connection, issue the SQL, and give us the data table, right? So what's left us for us to do in this method now?
We have to add in the list.
We have to convert.
ST list we have to add.
We have to
Data
convert
table.
this data table to
Student.
list of student, correct? So the last thing we need to do is convert list to, convert data table
List of students.
to list of student. Okay, so now we could write the code. It won't be too bad. Let me quickly show you how this code will look like. So the code to convert data table to list of students will look something like this. We will create an empty list, which we already did actually over here. So now we will do for each data row. So data row is a built-in class. In data table contains a rows collection. So we can go over every row in the data table. Okay? And once we loop through it, we can create one object of student st equal to new student. Okay, then we can say st dot student ID equal to dr of student ID. Okay, now anytime we, so this is the indexer provided on the data row. So anytime we try to read the column from the database, it's given to us as an object. Okay, so we have to convert it to, for example, typecast to an int before we store over here, right? And then very similarly, we can go first name equal to. You have two options. You can typecast it to a string, or you can also do toString on it. And so on, right? After you are done, you will do st list dot add st, and then at the very end of this function, so once you are done converting this, so this code basically continues over here, right? And then you will simply do return st list from your function, and you are done. Okay, so to summarize, what I'm trying to say is we break our work in two different classes in the data layer. Okay. The job of the data access is simply to take SQL and issue it to the database, right? What's the job of the repository at a higher level? Compose the SQL, okay? Issue it to the database, issue it to the data access layer, right? And then convert it to a strongly typed list. So this is exactly what we did. In this method called getEnrollment, we created the empty list of students that we'll be returning. We composed the SQL, right? We called our data access and issued this SQL. Once we got the data table, the last part of the code was what? To convert it to a strongly typed list, right? Okay, so now what about in our application that you'll be creating, and next lecture I'll give you all the details so that you can do a good job on it. Okay, what if somebody said, well, we like to display, for example, all courses that belong to let's say computer engineering, okay, or computer science. So what if we wanted one more method over here called get all courses, or get all courses being offered, okay?
Professor, I have a question.
Uh-huh.
When we return from that for each loop, Well, I mean, from the database, we included the course name, but course name is not part of the student.
It's not part of the student, so let me just say you created another class called student 2,
Student 2, okay.
and then let's make it student 2 and so on. So
Okay.
I just wanted to show you, just in case
Okay.
you have an extra field,
Mhm.
but that's a good question. Okay. Make sure that whatever you're returning has
It's
all the
matching, yeah,
fields.
it's matching.
Okay. And if it doesn't, you'll create a new
New.
class for it. Okay. So anyway, so let's pretend we wanted to write one more method. Let's call it get all courses in our repository class, right? So again, our SQL in this case will look like what? Okay, so let's briefly take a look. Our SQL will be, so this is for the get all courses. Okay, what will it return?
List of courses.
List of course, right? So pretend you've already created a class called course, which will have the fields matching your database. For example, course number, course name, credit hours, and any other detail, right? So pretend you already have a class. So as you're writing this method over here, what will be our SQL? SQL will be pretty easy, something like select star from courses, right? Okay. So anyway, after we issue it to the database, we will obtain something like data table dt equal to idac dot get many rows columns, correct? And SQL over here. And pretend you already have idata access idac equal to new data access. So you already created an object of it, correct? Okay, so now what do we have to do now?
Convert the data.
Convert the data table to what?
Course list.
Convert dt to
Course list of courses.
list of course, correct? Everybody agrees? Okay. So very similarly, what if somebody wanted to write get all or get courses which are available to graduate students? So get all graduate courses, or get all students that are registered in more than 3 classes, right? So you can see in all of these methods that we write in the repository class, the SQL will keep changing. Everybody agrees?
Yes.
Okay. However, this part over here, as of now, the last part, will also keep changing, correct? If we can make this last part
General.
generic, we will save so much effort because this is a tedious part. For example, if we were converting the student data table to student class and filling all these fields, if we can generalize it, it will save us so much work, because from then on, the repository will be simply compose SQL, issue it over here, and then call one line of code to convert it to the list. Okay? So the question is, how do we convert the conversion of DT to any list? So for example, what was the difference between here and this part over here? Here, what were we converting the DT to?
List of
List of
students.
students.
Convert DT, which is the data table, to list of student, correct? And here we were converting it to list of a course. Another case, we may be converting to list of faculty or professor or whatever, right? So as I had given you a hint, anytime you run into this type of situation where the data, the type of the data keeps changing, start asking yourself, can I convert it to a generic, okay? So if we were to convert it to a generic, what will we call over
List
here?
of the
List
List
of
of T. Okay, so now let's try to write a generic method for the last part. Okay, so now let's call this method convert to list. What will be the input over here?
List.
Data table. What will be the output over here?
List of the
List of T. Everybody agrees? And because it will be a generic method, after the name of the method, we have to put less than greater than T, right? So let me make it convert to list. And this will be list of T. Okay, so now let's start writing the code.
for
Okay, so now we will say for each. So first we'll create this list over here. So we will say list of
T.
T, let me just call it T list, equal to new list of T. Right, everybody agrees? Okay. For example, if we were doing this part,